Chen Liu, and today I'm gonna share my six place solution called interlabel Go. It's trying to on revealing a label correlation. Um, Here is the agenda. So I will briefly introduce myself. Um, Currently, I'm a first-year PhD student at Lidia Fridolina's lab, University of Michigan. My current research focus is developing algorithm for protein function annotation. Even though my current focus is doing very related to this competition, but prior to this competition, I did not have too many experience in protein function prediction or machine learning. I just took some course related to natural language processing (NLP) and have some experience on fine-tuning a large language model. So the objective of my CAFA 5 journey is to first using CAFA 5 as a platform to grow and learn and practice the application and also immerse myself in the field of protein function prediction. So I really appreciate and thanks for the host to give us a platform, a great platform like this. Um, okay, and here is the summary of my deep learning based model. It's very simple. It goes from query sequence, then it will feed into the ESM2 model, specifically the 3 billion variants. So I will then drag the last three layer, like hidden representation of last three layer, and take the mean of each layer, then feed to a fully connect layer for each of the mean. I will feed into a fully connect layer. Then I will perform a concatenation through those three layers, and then there's a feed forward layer. Maybe for BP aspect, there's a residue connection, and then then is a final output for confidence score. So this is a really simple model, and it takes very short time to train. It only takes around 3 or 6 minutes to train on a RTX 4090. So besides this deep learning model, I also use the BLAST to transfer the sequence homology to get a alignment-based score. So the final method is a linear combination of sequence alignment-based method and neural network method. And I think the key feature is the embedding extracted from the ESM model, and the additional feature may be like the bit score and sequence identity derived from BLAST P heaps. And the tools I use, so I use PyTorch for neural network training, and I use the NCBF BLAST P, and or Diamond for the alignment based method. So the uh, total training time would around uh, 1.5 hours, because I also use the five-fold cross validation, and I train a model separately for each aspect, so 15 total models. Um, so here is my feature selection. So as I discussed before, the primary feature is the embedding derived from ESM model, and based on the independent test set, which is also the test set changing is trying to replicate the private test set. 98% of the performance in terms of weighted F max can be achieved by the ESM features alone. And here is the figure. And so now right here, the interlabel Go plus is a linear combination of alignment KN and interlabel Go. And so as you can see, the deep learning based method alone can achieve very high. Oh, sorry. This is I probably messed up the slide, but this is the average score for the three aspect in. Mm, so the training method I use is five-fold. So first I perform a five-fold random split. So it's and train a separate model for each aspect. And the final prediction for each totem was the mean score across the 5 models. And I think the most important things in my model is I use a innovative loss function. So first I utilize information to weight soft F1 loss at across protein level and gluten levels. Um, this is different from the other deep learning model, which usually use binary cost entropy loss. And also I implement rank loss to capture label correlation, also showing the equation below. So basically, this would would doing would introduce a new term we call an S0 term. So we will perform a pairwise comparison between all the positive term between the 0 term and all the negative and 0 term. The goal is we want all the positive term have higher value than the 0 term, and all the negative term have lower value than 0 terms. And those loss functions are combined through simple multiplication. So and finally, the linear combination of from the DNN method and alignment method was performed. The optimal weight was determined from the validation data set. And so the interesting finding of my interest finding is the innovative loss function would improve the performance a lot. I remember in John's team, and they also tried some different loss function, but they say they do not improve the score. But this is not in my case. It's the score showing right here. If instead of using the interlevel ghost loss, if I replace the loss with binary cost entropy, the performance of the my deep learning model would go down by a huge amount. And so the simple model would be the only use the deep learning model, and instead of using the 5 model from 5-fold, we can use 1. But if we're using this approach, the score is around like 91% of the final score. But I don't think it's worth it to use the simple model, because the even if I have a 50 model for deep learning method, but all of the model are relatively simple, so I can get we can get the like prediction for around 2,000 target within 10 minutes. So I don't think worth it to use the simple model. And here's the performance comparison on simple model and other model. And lastly, I want to thank Dr. Chen Xinjiang and Dr. Lydia Ferdolina and all the lab member of Lydia Ferdolina lab. And that's it. Any questions?